Hello, my name is Carl Cook, and I'm President and Chief Technical Officer of Biocomp Systems. And this is a video about swarm roles and relationships in Dakota 3. Somebody in our forums wanted to know, how do the bots and all the add-ins and everything all fit together? And this is a real quickie to basically describe that. So here we go. In the beginning was the bot, and the bot was good. And basically the bot contains the parameters for a trading system that is being walk forward adapted. And the bot does not live alone. He has brothers and sisters, and they're in a swarm. And each individual bot, therefore, is a manifestation of the values of parameters of a trading system. So each bot has maybe a long moving average set of periods and also a short moving average set of periods in a moving average crossover system. So each bot has the same parameters with different values within a range that's specified by the trading system that's being walk forward adapted. And so bar by bar, these bots are being fed data, and they're skitter about based on their performance. Well, how do we skitter them, and how do we know what their performance is? All right, so the bots in the beginning need to be initialized, and that's either randomly scattered throughout the parameter space of the trading system, or maybe in some regular pattern, or whatever. Maybe they're all piled in one corner. Somehow those parameters of the trading system need to be initialized. Then, bar by bar, they need to be adjusted. And that's where an adapter add-in comes in that says, I'm going to move these parameters based on the equity performance of the bot. So this bot has making this many, $1 trillion a year, and it has these parameter values. Well, that bot over there is losing money or madly and has those parameter values. So I want to move away from the bad and move towards good so that I adapt the trading system according to a look back period of market dynamics. So that's what the adapter does, is he's got access to the entire swarm, and he can look at each bot and its parameters and its equity performance. Okay, we know the parameters came from the trading system, so where does the equity performance come from? Well, it comes from the bot performance block, which is a very quick calculation of equity performance of that bot over the last so many bars. Okay? Now, once you have all these bots, and they're making or losing money, their signals need to be merged together. So each bot is saying, buy, sell, based on the result of the trading system and the parameters that it's holding. So each bot has a different opinion as to whether or not you need to buy or sell or hold or do whatever. So those need to be merged together. And so we have an add-in called a model merger, which then has access to the entire swarm, can look at each bot, look at its performance, look at its parameter values, look at what its signals are, and merge those signals together. And that can, of course, have an equity calculation put on that, and so that would be the swarm performance. And those signals go on up to the system, the Dakota system. That system gets those signals merged out of the swarm, passes it through what we call an equity engine, which is more of a full-blown calculation of equity statistics and equity curves and the trades and all that stuff. And it goes into the system and can be displayed to the user as a price, signal, equity curve, statistics, trading report. And then the signals, of course, then are interpreted coming out of the system, either by a human or sent on to another package. So that's kind of the simple view, but there's more. The main swarm can also have child swarms, subordinates we call them, and they also can have initializers, which can be different, adapters, bot performance, all which can be different. The trading system and the subordinates swarm should be the same as the trading system in the parent swarm, and so that the parameters of the bots make sense to each other, so that there's some congruence between the parameter values. So perhaps one of these lower swarms is a sentinel swarm, where the bot parameters are spread evenly across the parameter space for the trading system. Dakota users will know exactly what I'm talking about. A sentinel swarm that has a null adapter so that they don't move. They're just sitting there in space. They've got this like major look eye out over across the entire equity space of all the different parameter values. And therefore, maybe some of them can say, oh, look over here. Man, we're making a lot of money over here. And, then what do? Well, you've got another add-in that's a mover. And he can go and say, oh, I'm going to go take a look at that bot that's really making the money down there in the sentinel swarm, and I'm going to move it up into the parent swarm and eject one of the bots out of the parent swarm, or clone the bot and throw it in, or whatever. You can add, change, remove bots with the mover. And so, also maybe another swarm, subordinate swarm. I've never tried it, but an idea came to me as I was making this presentation that maybe one of them's a junk pile. And every time that there's a great one in the sentinel moves up to the parent, you grab the least performer of the parent, and instead of throwing it away, which creates an evolutionary algorithm, by the way, you could take that and throw it into the crap pile. And maybe that crap pile, one man's junk is another man's gold. So maybe there's some value into throwing stuff into a crap pile and regrowing something that's useful out of a subordinate swarm. There's a lot of different things that can be done and architected in different ways. Anyway, the purpose of this presentation was to give you an idea of what's the roles and relationships between the bots, the swarm, the main swarm, subordinate swarms, the add-ins, where they go, and what they do. And I hope that this helps. And I appreciate it very much. Thanks for your time.